Here's our problem. Here's a situation that we're going to examine. Suppose your phone falls out of your pocket when you're sitting in the bleachers watching a football game.
I'd cry.
You wanted to get the best view of the field, so you were sitting in the top row, which is 40 feet off the ground. Interesting question. How fast will the phone be falling when it's 1 foot above the ground?
You gonna get the equation?
Okay, now question. Is it gonna go, is it gonna be falling faster than if we were only 20 feet off the ground?
Yes.
Yeah.
Yes,
Gravity.
why?
Gravity.
Gravity accelerates it, okay? This is why it hurts more when you fall from 20 feet than if you fell from 2 feet, okay?
Does it hurt?
So, huh?
Does it hurt more?
Yes, it does. I've experienced
Oh, wow.
too many of those. Alright, so here's the thing. Now notice, we don't care when, or, you know, what's the height or whatever. What we're looking for here is a speed. Okay? How fast is it going? And notice, I stopped it at 1 foot off the ground. We could get closer if we wanted to, but I just made it 1 foot. What's its speed when it hits the ground?
0.
0, because it just hit the ground and the ground stopped it, right?
Yeah.
Okay? So that's the problem. We can't look right on the ground, but we're going to look at it when it's 1 foot off the ground. And of course we could get closer and closer with shorter heights. Okay? It is going to be approaching the ground. So here's the thing. Here's the thing. If we want to figure out this speed, you know, especially when they design these things, or when they design the cases to protect these things, these are some of the calculations that they might figure out. How fast is it going to be falling? If we want this thing to be able to survive a 40-foot fall, then how fast is it going to be moving at that point? Alright? So then they can figure out with force equals mass times acceleration and all that kind of stuff, and they can figure out how much force it's going to be hitting the ground with. But anyways, does anyone remember what the formula for a falling object would be?
V equals
T squared.
Whatever that is.
Okay.
VF squared.
Vt squared. Okay. It's Vt squared. And the velocity at any given time, okay, it's, you have 1/2 times the acceleration, right? So, what's the acceleration of gravity?
9.8.
9.8 meters per second squared. Do you know what it is in feet?
11.88 feet.
No.
I mean, 11.88 meters. 39 feet.
27. Well, your whole formula is wrong. No.
No.
Wait, I have a calculator.
Forget about meters. So we're not converting everything to meters, okay? We're going to stick with the 40 foot and 1 foot, so we need our acceleration to be in feet. It's 32 feet per second. Technically negative 32 feet per second because it's going down. Alright? So the height of this phone at any given time, we're going to use D, alright, its distance off the ground, is negative 16t squared plus 40. Okay? Why do I have the plus 40? That's how high we started. Okay? So, that's going to be our formula. Now, one thing that we need to do, and this is going to be the first thing that you and your partner can do, is figure out what that point will be when we're 1 foot off the ground. So the 1 foot is which coordinate of our point? Is it our x coordinate or y coordinate?
Y.
It's the y coordinate, okay? So figure out the time that we are 1 foot off the ground. That'll be your first task. Okay? So go ahead and do that. Work with your partner.
I don't think it's the right answer.
I hadn't do it in years.
We're in America. We use feet.
Oh.
Because we were building
I know, right?
the world.
So bad.
I don't even
So,
Is this right, Jacob?
It's also like Papua New Guinea.
Oh, did they actually use it
I think
there?
it's two countries. It's also like Papua New Guinea.
Wait, this is right?
Yeah.
Okay.
1 plus 40 divided by
So
0.
we're right?
39.
Please step out of
I'll
it,
find it.
Earl.
I'll find it.
Okay.
I was
right.
man.
Wait, what was
You'll be okay.
So
Only.
These are the points.
1.5.
Oh.
Yeah, 1.56.
So what are you doing to get this?
Plugging in D for 1 and solving for T.
Plug in 1 for D and solve for T.
Oh, it's it? I mean, one for. Oh.
1.6.
Okay. Let's go ahead and round this to 2 decimal places. Okay.
1.56. 2 zeros.
Oh, that's because you added instead of
Question,
subtracting.
why did you put a 1 and not
39.
39?
How's it going?
That's a lot. No, okay, not one.
Okay. Alright, so I've heard it from a few of you. The time is
1.56.
1.56 if we round to the nearest hundredth of a second. Okay? So we have 1.56. Where was our starting point?
0.
0, 40. Okay? Time was 0. We were 40 feet off the ground. Okay? So,
Why do we plug in 1 for? Oh.
because we want
Yeah.
the speed when it's 1 foot off the ground.
Yeah.
Okay? Now, here's something important to make a distinction with. Alright? We don't want average velocity. We want the instantaneous velocity. Okay? Now, think with me here. How would I find average velocity?
You'd average
Slope.
the slope.
Okay, get the slope between those 2 points. Alright? It's distance traveled over the amount of time elapsed, right? So the average velocity is going to equal
1.56.
14.5.
40 minus 1 over 1 minus 1 point, or 0 minus 1.56. And you got what?
39 over
39 over negative 1.56. So we get negative,
25.
25 feet per second. Now is that the speed we're looking for?
No.
No. Our speed is actually going to be much faster than that. Okay? Because it started out at 0 feet per second, and then the longer it was falling, the faster it was going. So sometime probably around, 0.8 seconds, it was going 25 feet per second. But it's not going to be at the moment we are looking for. Okay? So we're about to get to the main thing that you are going to do with your partner here. And you guys actually already identified the key concept we're going to use. And that is the slope. Okay? The slope. Now, so far we have these 2 points. I just copied them over here. Velocity is the rate of change, right? So is slope. The thing that makes this challenging is, unlike a line where the slope is constant, here it's changing because of that gravity speeding it up. Okay? So, the rate of change, if this is the point I want the rate of change at, okay, what we just did is we found the slope of this line. Okay? What line do we actually want?
The other one?
What other one?
One tangent to
Isn't this?
What'd you say?
tangent to it.
The one tangent to it, okay? What we actually are looking for here is the slope of the tangent line to the curve. The tangent is the line that touches it in only one point. Okay? So it's going to touch right at this point 1.56 1. The problem is you have to have 2 points to have slope, right? So how could
You
we
use 40.
get this?
You use 40 as your y coordinate.
Well, that's what we did at first, so we got the negative 25. This line right here has a slope of negative 25.
Use the 0.
What could I do with this point?
Something
Instead of using this point,
Use.
the end point. Nope, that doesn't work.
It's gonna be a tangent, that's what it is.
Just
Nah.
0.
What if I used this point instead? Is its slope gonna be a better or a worse approximation of our speed? It's gonna be better. What if I used a point even closer to the point I wanted?
It'll be better.
It'll be even better, right?
Isn't this the limit?
It is a limit.
Oh man.
Okay. It is a limit.
Oh man.
Yeah, call.
So the question is, what am I finding the limit of? I'm finding the limit of my slope
As you approach 1.
Two.
as this x-coordinate approaches the x-coordinate I actually want. And we could say as the height approached to 1, but just in the whole concept we usually will do it in terms of the x-coordinate. Okay? So, I want you guys to observe this. I'll do the first one here with you. Get this color change thing, I don't know why they did that. Alright? So what we're going to do is we're going to find
Oh, okay.
the slope between the point we want and different points, okay? Now first of all note, if I have this right here, 1.561 already, but you know, the slope here is undefined. I don't know, I can't find the slope between a point and itself. Okay? So the first thing I'm going to do is, if I plug in a 0.5, 0.5 squared is a quarter, right? So 1/4 of negative 16 is a negative 4. Negative 4 plus 40 is 36. So now look, I'm finding the slope between this point here and this point here.
It's going to be negative.
So 36 minus 1 is 35. 0.5 minus 1.56 is a negative 1.06.
Comes out to about negative 33.
Negative 33 something?
0.0189.
Okay, so negative 33. We'll just round. Okay, you guys will see the idea. Does everyone understand what to do?
No, not really.
Okay,
Yeah.
you're going to do the same process. Find the y coordinate at point 8, and then use this point and the point 1.561.
You find the slope from everything with 1.5.
Yeah, you're using this point right here on all of them
So we're going
in the slope.
do the limit.
Okay?
Oh.
So work with your partner here to get the rest of those points and slopes. You could even kind of team up. One of them,
Where
one of
did
you
you
get.
get the 36 from?
Alex,
You just plug in the 0.5 into D.
Oh.
Okay, I'll do.
From 1.3 down.
we divided by 1.56.
It's slope. So the change in your y's over the change in your times.
We find out we use 36.
Do you want to do the slopes?
I did 36 minus 1, and I did 0.5 minus 1.56 to get these. You guys know how to do slope.
Sadly. Sadly. Sadly.
Yeah, but I don't know what to do after I get this. I have to subtract him from him, 1.56. Minus 1. Okay, that makes sense. Yeah. Yeah, I'll do up to 1.2. Oh. Okay.
Should it be inverse, like d of t should be the inverse of the slope?
Yeah, it's falling, right? So our
Yeah.
height should be getting lower. Our speed should be
Getting fast.
getting faster.
Okay.
And all of your speed should end up negative because you're going down, right?
Are we finding?
Nobody.
Do you want us to find F also?
What?
F is this point right here.
Not very.
Or F is that point right there.
Oh, so even, oh no, slope F, that's what I'm saying.
The slope from F to this point.
Oh.
Alright, so what do you get for the distance when time is 0.8?
29.76.
29.76? Alright, how about at 1 second?
24.
24.
24?
Yeah.
1.2 seconds.
16.96.
16 point what?
96.
Okay. How about 1.3?
1.96.
And 1.4?
Didn't get there yet.
8.6?
4.
Okay. And
4.
4? Alright. So those are all the heights. Notice it's falling. Okay? It's getting lower. Now, our speed should be increasing in the negative direction. All of these ought to be negatives because we're still going down. Alright? So, at 0.8, what was your slope?
Negative 37.84.
37.8, okay.
Negative 41.
Are you gonna write for me here? There we go. And then what?
Negative 41.
41.1.
41.1.
And then negative 44.3.
Negative 46. Negative 47.75. And negative 50.
Okay. So, you could say it's going a little faster than 50 feet per second, right?
So how would we write that as a limit?
Good question. Okay. What we have to do in order to consider this in terms of a limit is we have to look at not as two separate x coordinates, but as this is the x coordinate we want,
So we're approaching.
and then each of these is a certain distance away. And what's happening to that distance?
It's decreasing.
It's decreasing, okay? So here's horizontally, this is my distance away. We'll call it h. Alright? But as these points got closer, what happens to h?
It decreases.
It's decreasing, okay? Until, what's the goal? Here's the limit idea. H is going to approach 0, okay? Now, watch this. Okay, it's a different graph so you can see your h a little better. But notice, h is approaching 0. As we come towards this point here, this is just a generic function with a point x, f of x. Okay? This point that we're talking about, as it's getting closer, is x plus whatever that distance is, x plus h. And the y-coordinate would just be f of x plus h. Alright? Does that make sense? So here's the limit. We said we were going to take the limit of the slope. Slope formula says take the y-coordinates and subtract them. Look, f of x plus h minus f of x. And that's over the x coordinates subtracted. So I have x plus h minus x, that's just h. So here is the limit as h approaches 0 of f of x plus h minus f of x all over h. This is the definition of a derivative.
Oh,
Okay.
no. Oh, no.
What we were just doing is trying to find the derivative. It's the slope or the rate of change of a tangent line at any given point on a function. Okay?
This is where my math gets hard.
Okay? This is where it gets cool because this is, remember I told you, limits are the basis of all of calculus. The two main pillars of calculus are derivatives and integrals. This is like the foundation for both of those pillars because both derivatives and integrals are derived from limits. Okay? So, notice some notation here. Derivative can use two different kinds of notation. One is this dy dx, dy over dx notation. That's the derivative of y with respect to x. Or you can use this notation, f prime of x. I'm not going to make a huge deal of that now because when you talk about calculus later, you'll learn that. But I just want to look at it purely from a limit standpoint. Okay? So, let's go back to that problem and use this definition. Okay? And we're running out of time, so I can answer a question individually if you'd like, but let's take our function. Our function was negative 16x squared plus 40, right?
Yeah.
So any given point, so that's d, okay? We want the derivative. So what we're going to do, let's say that's d of x. What would d of x plus h be? How would I find that?
Well, it
Multiply, no, I like.
How do you evaluate a function?
Well, negative 16x squared plus h, right?
Negative 16
X plus h.
x plus h squared plus 40, right? Right?
Nice.
So now, using our definition, the derivative of d, so d prime of x, we'll call it, is the limit as h approaches 0 of negative 16 times, and I'm going to FOIL this just for time's sake, so x squared plus 2xh plus h squared plus 40
all over.
minus
All right.
f of, or d of x. Here's the d of x plus h minus d of x. So minus the negative 16x squared plus 40 all over h. Now, can we do direct substitution?
No.
Can we?
No.
No, h is 0, right?
You have to rationalize it.
So check this out. This is where this is kind of cool, okay? If I distribute here, I get negative 16x squared minus 32xh minus 16h squared plus 40 plus 16x squared minus 40. So watch this. Watch this. This cancels with this. This cancels with this. Right?
And then just, can you
So watch this. Limit as x approaches 0 of, see what's left? They both have h's, so I can cancel it out with the denominator. And I have a negative 32x minus 16h. That you can do direct substitution with. this is 0, and you just get a negative 32x. So when x is 1.56, the speed is 1.56 times negative 32. Okay?
Hey, is this in the list?
Cool stuff.
Is this in the
Mr.
list?
Dixon,
Do
do you want me just to leave this here?
Yeah, you can leave it there.
Okay, thank you.